5.2. The whole section is about multiplying polynomials. Okay, today let's call this part 1, which is really all we're going to be doing today is multiplying monomials, which is the most important part, because if you can't do this, you can't build anything on top of it. So you have to be able to multiply monomials. Okay, first and foremost are 2 shortcuts that I would advise against using, but you need them, because in case you're dealing with big numbers, you can't write it all out. But the 2 huge shortcuts are these monomial rules, just 2 of them, and they come up over and over and over again. And what that is if you have x to the a times x to the b, you could add those together, and that's x to the a plus b. Okay, we'll talk about y, I'll do a little example of y. And the other shortcut is if you have x to the a, and you raise that to the b power, you get x to the a times b. Okay, you can obviously see why multiplication becoming addition and power becoming multiplication can easily get switched. People could add these 2 instead of multiplying, or multiply these 2 instead of adding. So really easy to see how that can get switched. Okay, and they will. So I'll just show you why really quick, not like in a rigorous proof or anything, but just why this is true. Okay, think about it like this. If I have x to the 3rd times x to the 4th, that's x times x times x. That's what x to the 3rd means. It means 3 x's multiplied together times, and then 4 x's multiplied together. It's louder, but close the door, okay. And even though I wrote that one big dot in the middle as big, one of the multiplications isn't any more important than any of the others. So this is all just times, 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 times. So I could write these 7 x's as just x to the 7th, right? And that's why the shortcut is I can just add whatever number of x's I have here and whatever number I have here as x to the 7th. Now I would advise you to expand it out, if possible. Okay, and this one, similarly, there's no magic. If I have x to the 5th squared, the reason I don't add those numbers, the reason I multiply them, is because this is equal to x to the 5th squared, so times itself. So if I were to write that out, that's x times x times x times x times x, 5 of them, times x times x times x times x times x, 5 of them. So how many x's do I have total? 5x to the 10th. So you could have used the shortcut and gotten x to the 10th, because it's x to the 2 times 5 is x to the 10th. Or you could have expanded it out like this and said, oh, now it's x to the 5 plus 5, which is also x to the 10th. So lots of different ways you can see it, but I would really advise you to double check or expand, because that's a super common mistake, is switching these and just, 2 times 3 or 2 plus 3, is it 5, is it 6, which one, and just interchangeably mixing those up. So my hint is when the numbers are small, when the, shouldn't say numbers, when the exponents are small. I would expand it out. Instead of using shortcuts, okay? Alright, so that's part of the biggest lesson. Okay, I'll do a couple examples with you from the book. There's really only 2 other things I'm going to show you, and then I'm going to have you practice all this because so many mistakes will happen in this part. And again, you can't build anything on top of polynomials if you don't get this. Okay, so first ones would be things like 2, 6, and 8. So x to the 12th times x to the 4th. Number 6 is x to the 4th times x to the 3rd times x to the 5th. And number 8 is 8 to the 7th times 8 to the 10th. Alright? So what would the first one be?
X to the 16th.
Yeah, this would be x to the 12 plus 4, or x to the 16th. Because, and just thinking about it, I've got a bunch of x's, 12 to be exact, times a bunch of x's, 4 to be exact. So total I've got 16 of them all written out in one line. Alright, what about this next one?
X to the 12th.
Yeah, because I just go 4 plus 3 plus 5, because again, it's just 1, 2, 3, 4 times 1, 2, 3 times 1, 2, 3, 4, 5. Write it out, bunch of them. No multiplication here is more important than the other. This is just a long line of multiplication. So yeah, it's x to the 12th. Okay, here's the one that tricks people. It's no different, right? What would this one be?
8 to the 17th.
Yeah, it should just be 8 to the 7 plus 10, or 8 to the 17th, because this is talking about the number of 8s you have multiplied together. I have a bunch of 8s. I'll write it in green, because I've done that for the others. I've got 8 times 8 times 8 times 8 times dot 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 times 8 times 8 times 8. So when I count them up, I'm saying I've got 8 to the 17th. The common mistake is,
People multiply 8 times 8.
yeah, and say it's 64 to the 17th. That'd be way more 8s. That'd be double the amount of 8s, right? Instead of saying I've got 8 times 8 times 8, so I've got a number of 8s put together, people accidentally combine these. But you didn't say this was x to the 3rd to the 12th, right? You didn't say this was x squared to the 16th. You left the base, because all these exponents are a count of how many of them there are. This is saying I've got 12 x's times 4 x's, so total I've got 16 x's in a big clump all glued together. Okay? So that's one big part. The next one, which is one of the most common mistakes in algebra, I'd say probably one of the top 4 mistakes in algebra. I'll write the most common mistakes here. So the most common mistakes. For my almost decade of teaching algebra, okay? Okay, number 1 is just simple arithmetic, right? Like 2 plus 5 and saying like 8 or something, right? Or just dropping a negative somewhere, right? So it's a really common one. The other one is not distributing a negative. And the other one that we talked about, these are both like first week of school. The other one is x plus 3 over 3 and canceling just one part of the group. And that's going to be really common as we come here into polynomials. Okay, this next one that we're going to talk about right now is also really common. If you have a plus b squared, that is not equal to a squared plus b squared. People think they can distribute this power, and that's what we're going to talk about right now. Alright, so all of these 4 mistakes come up on every test over and over and over and over and over. Okay? So, the next one is distributing exponents. You can do this with one term, right? Just like everything in math, that addition and subtraction sign breaks all the rules. With monomials, you can do so many things. With polynomials, you absolutely can't. Okay, quick example is number 16 in the book. So 16 is 4y or x, 4x to the 3rd, right? And I'm going to write over here not 4 plus x to the third, you could not say that this is 4 to the third plus x to the third. Absolutely not true. Okay, totally 100% not true. I mean, quick example of why that's not true. Just think about 2 plus 5 squared. That should be 7 squared is 49. If you distribute it in, 2 squared plus 5 squared is 4 plus 25 is 29. Different numbers. Not true, not equal. Okay, but when it's multiplication, you can, whoops, I wanted green. You can do this and get that this is 4 to the third, x to the third. And it's not magic. The reason you can do it is because write it out. This is 4x times 4x times 4x, or in other words, 4 times x times 4 times x times 4 times x, where no multiplication is any more special than any other multiplication. And I can rearrange multiplication. I mean, I know that 2 times 3 is the same thing as 3 times 2. So I can rearrange the order, so I just rearrange this to be 4 times 4 times 4 times x times x times x, and so it's 3 4s times 3 x's. So that's why you can do it with multiplication, because it's one big chunk of stuff glued together, and all you're doing is pushing all the 4s over here and the x's over here, which you can do with multiplication. Okay, so you absolutely can do that, which you would then do 4 times 4 times 4 is 64 x to the third. Okay, whether you did it with the shortcut or not. Okay, be really careful with that. Okay, I'll do one more example of that, just to bring in a negative, so no one's surprised by a negative. Let's do 22, which is negative 2y to the fifth to the fourth. All right. So what do we get? How would we do it?
4 y to the fourth, 5, or no, my bad, it'd be y to the 20th, right?
So yeah, so it'd be y to the fifth raised to the fourth power, because you could distribute this in to the y to the fifth, but you'd also distribute it into the negative 2, so we'd have negative 2 to the fourth, so that's negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2, positive 16, times, and then what would this one be?
Y to the 7?
No, it'd be a 5 and a 4, so times, so it'd be 16. Why, that's right. Again, only because it's one term. Could not do that if it was 2 terms. Okay? And that's really the heart of it. So, the last thing we're going to do.
So when it's more than one term, you just distribute it, so like right here with 2
Exactly.
plus 5, it just goes straight to the 5, and you don't carry it over to the
No, so that's what, save that for Monday, because the idea is you don't need to write this down. As soon as you have a binomial plus a binomial, you have to distribute this one to all of those, this one to all of those, and so the combinations get crazy. And that's why dealing with more than one term tends more than one term, and that's why it gets messy. And that's the whole study from 5.2 on, is all about this. And how do we multiply it together and get something, and then how do we take that apart to go from the end result back to this. That's all of chapter 5, all of chapter 6. Is this idea of more than one term times more than one term and the mess that ensues. Yeah. So yeah, when you have, like, say, x plus 2 squared, you need to write that as x plus 2 times x plus 2, distribute it, so you get x times x times 2, and then this 2 times this x, and then this 2 times this 2, and then combine like terms, and get this, right? So more mess, again, not today, we're gonna do that on Monday. I don't wanna deal with polynomials today. So the last thing we got is just multiplying monomials, which we already just did, so I'm not gonna write any new notes, but an example, 26 is 8x times 3x, right? So how could we do 8x times 3x? how can we do that?
8 times 3.
Yeah, we just rearrange and do the numbers first. So 8 times 3 and x times x, so it's 24x squared, that's it. Right, so we multiply the numbers together and the x's together. These don't even have to be like terms. That was a great question that somebody in my last class asked. So let's see, 30 is another example where now they're not like terms. So you have negative 6y to the fourth and 2y to the third. So these aren't like terms. So you could not add or subtract them together and say I've got 2 blue cars plus 5 blue cars is 7 blue cars. But imagine multiplication and division like super glue. I could super glue anything to anything else. I could super glue this whatever you call it, lid to the wall. I could super glue this stapler to the projector, right? They don't have anything in common, but I could take a bunch of super glue and just stick it to anything. That's what multiplication is. There's no rules about I couldn't multiply this times this. You can glue anything together with multiplication. So when I multiply these, I just multiply the numbers, because again, it's all just multiplied together. So, negative 6 times 2 is negative 12. Y to the fourth times y to the third is? Why is that? That's it. Okay? And again, the next step where we're going to leave off is distribution. This is just like normal. And as long as it's of a monomial, right? As long as it's one term, distribution is totally normal, like we used to do it. The only difference is, oops, I always do that, I leave off the last letter, I'm in such a rush, I'm so excited. So 36, nothing new, just getting used to this idea of multiplying 2 monomials where the numbers multiply, the variables multiply. So we get 6x times x plus 5. So it's just like if we had 6 times x plus 5. There's no difference. Just keep track of the x, but I mean, you just multiply it in. So this is 6x times this, 6x times this, so 6x times x plus 6x times 5. So what do we get?
6x squared
Yeah,
plus 3x.
that's it. Right? It obviously gets a little harder than that, but there's no new things. And this takes you up to 5.2 number 54, I think? Yeah, 54. I shouldn't say up through. Okay? So about halfway through this section, and then from there on, it's new material, so I'm splitting the section in half. And on Monday, we'll start with that second part, but let me do just one more example or so. Same idea, it just gets a little, there's more x's and more y's. No new rules, no changes. Okay, so let's do 2 more. Let's do 42 and 48. Okay, so 42 is negative 5y, 6y plus 7. And let's have you guys try both of these, and then we'll do them together. We got a nice intimate crowd here. So 4y squared, 5y squared minus 6y plus 3. Okay, so these will be the last 2 examples you do together. And that's it. So it's all just multiplying these monomials and knowing these basic rules of how to multiply, how to deal with exponents. Alright, so do it on your paper. See what you get. So that way you can kind of grade yourself and say, all right, I'm getting this, or, ooh, I dropped a negative somewhere. All right. So I'm just going to write it first, not write the answer. But negative 5y times 6y plus negative 5y times 7. This one I distribute this into all 3. So I get 4y squared times 5y squared minus 4y squared times 6y plus, plus 4y squared times 3. So what do we get in the first one? Yeah. I like it.
Negative 35y.
Perfect. That's it. And then the second one?
20y to the third.
Oh, fourth, yeah.
My bad.
No worries.
Minus 24, y to the third.
Yeah, and that's a common problem is people do y squared times y and they just say y squared. You're multiplying by another y. You're saying I've got two of them times one more. That's exactly the definition of y to the third, is I've got three y's multiplied together. Here's two of them times one more, so y to the third, and then plus
12y squared.
yeah, 12y squared. And that's it. Okay? If you can do that, the rest of the section is so much easier. This is where the mistakes come. It's not so much with the how do we multiply the other stuff, which I'll just show you really quick. I'm not gonna do notes or a problem, but just if you had something like x squared plus x plus 2 times 3x minus 5. We would just take everything from here and distribute it, the next one distribute it, and then even this one and distribute it. So you get 6 terms coming out. But you need to multiply two monomials 6 times over here. That's where the mistakes happen. It's not with the, oh yeah, you distribute it. It's more that what is x squared times 3x? And if you miss one single exponent, the rest of the problem is wrong. So the mistakes happen in the first part of this section, just like as you're looking at how you did on the first test, you're like, oh, my mistake was I forgot a negative sign. I said 1 plus 2 was 7, right? Things like that, that's chapter 1, section 1, probably accounted for 60% of your mistakes. So when I say really focus on this, pay attention to detail, learn some tricks to prevent errors, I mean it, because this is where the mistakes happen, is how do you multiply a single term times a single term and get out the right answer? Okay. Alright, so you guys got about 15 minutes, you work on this, otherwise have a good 4th of July, and yeah, test is on Tuesday.